our cell phones, take a selfie, and post to all of our social media to let AWE know that you were here using the hashtag AWE2024. And so now, our next keynote, building immersive 3D content for any device with WebXR. Please welcome to the stage co-founder and CTO of Zappar, Connell Gauld.
Hello everyone, great crowd, good turnout, nice to see everyone. I'm Connell, the CTO and one of the co-founders at Zappar. And at Zappar we've been in the immersive industry for 13 years now, which is long enough that when I started I had hair and I now have a hat. Over that time there's obviously been a huge amount of evolution, and one of the things that's evolving as we go is a technology called WebXR, which I'd like to talk to you about today. WebXR is a foundational technology that is built into the browsers on headsets. And what it does is it enables web pages that users browse and visit in those browsers to provide immersive, interactive content to those users. Let's see what that looks like. So in this example, we see Dilmer, who's a XR content developer, and he's produced a simple piece of educational content that you see on the right here. It's a space-themed interactive experience, and he's viewing that, in this case, on a Magic Leap 2. But, as we'll come to, the beauty of WebXR is this experience works without modification across other headsets, such as Quest, Vision Pro, Pico, etc. Today we're going to, or I should announce, I suppose, the subtitle to my talk, which is WebXR, the good, the bad, can you see where this is going? And the ugly. That's just fair use, I haven't licensed that. What we'll see is that there's a lot to love in WebXR, but there are also some challenges that come about because it's an emerging technology and because the different devices implement the specification in different ways. Let's start with the good. The premise of WebXR is you can build content once and you can run it on any device that supports the specification without modification. Because content through WebXR is delivered through the web and through the web browser, you can leverage the existing web ecosystems around. And that goes all the way from front-end web development community through to the ecosystems in organizations surrounding deployment of web content. So for example, analytics like Google Analytics or Adobe Analytics, or the use of Azure or AWS or Google Cloud for hosting web content. Often organizations have structures in place to support front-end web development in their organizations, and you can leverage that as a content developer with WebXR. There are no App Store submission processes with WebXR content. Users access that content just by visiting a link in the web browser, and you haven't had to ask Apple or someone else to approve that content before you distribute it. And as a result, users don't have to download any apps to access WebXR content. They can get straight into an experience very quickly. Device support for WebXR is broad. This is another good slide, if you like. So support includes the web browsers on Magic Leap, on Quest 2, 3 Pro, etc., on Pico, and indeed Apple have released support for WebXR in the version of Safari that runs on Apple Vision Pro. The version that they launched with last year had the WebXR feature behind a flag, a feature flag, which means users have to go into settings and turn it on. But it's great to see that with the next version of Vision OS, version 2, that Apple have just released a preview, they're enabling that feature by default, and indeed have fixed some bugs with the implementation of WebXR on Vision Pro. The thing that's great, yes, I think we can all be very happy of this. The thing that's great about it is it's great to see Apple embracing an ecosystem that's open, like WebXR, and it's a really good news story for our industry as a whole. I'd like to talk about one other headset, and this is the first of two shameless or perhaps shameful plugs during this talk, which is, at Zappar, we've also built our own mixed reality headset. At Zappar, we like to do things a little bit differently often, and Zapbox is very much different. It's an affordable mixed reality headset that is a frame like this that you put your phone into, and it comes with two Bluetooth controllers with buttons. And the whole kit is just $90. It supports color pass-through, so full mixed reality experiences. And indeed, we've just launched support for WebXR through Zapbox. And what that means is you can build a piece of content, like we saw with Dilmer's, and it run on a device that's $90, and it runs on a device that's $3,500, and it runs on a spectrum of devices in the middle. And that's so important for making sure this technology gets out to as many people in the world and as many use cases as possible. You can find out more about Zapbox at zapbox.io. It's available for purchase online now, and we're also stoked to announce that from this summer it will be online at GameStop and stocked in a few of their stores too. You're welcome to come to booth 217 and try Zapbox on. It's one of these things that, to describe that it's a headset with a phone that you stick in it and you put it on the front of your face, it seems like that might not actually be very good, but the overwhelming response we get when people try this is, that's way better than I expected. And so we would really love for you to come and give it a try. This is where our story gets a little bit sadder. Let's talk about the bad. And I should just say, as a spoiler alert, there's an emotional roller coaster we go through in this talk, so we do come back to the good at the end. WebXR is a foundational technology. It provides the building blocks for immersive content, but it doesn't do very much to help the development process or to make it efficient. Now, you might think that this is a criticism of WebXR, but it's not. What this is just really a description of what WebXR is. If we look at this stack that runs an experience in your web browser, we can contextualize WebXR and understand why it's like this. WebXR sits at the same layer in the browser as other technologies that web pages use, such as web audio for making audio in web pages, and networking like WebSockets and WebRTC that powers things like Google Meet and online multiplayer games in browser. There's a layer that sits above this, the ecosystem, and that includes elements, frameworks, SDKs, etc., a lot of which have been built by the open source community that sit on top of this foundational layer and make the developer experience much better. So a great example of this is 3JS. It takes WebGL, which is the underlying 3D rendering technology in a web browser, and makes it much easier for developers to describe a 3D scene. There's, in addition, fantastic developer tooling in the front-end web community, tools like TypeScript and big repositories of SDKs like NPM. These sit on top of the browser technologies, and they're still, if you like, quite developer-y. We'll see that in a moment also. In any case, they make it much easier and they're an important step for people building content. We do fall slightly further on the emotional roller coaster before we hit the turn. We are on the ugly stage. Each device that supports WebXR implements the specification a little bit differently. Sometimes that's because devices are inherently different. Sometimes it's because there are bugs or issues with their implementation or places where the specification is maybe ambiguous. So to give an example of some of these, some devices support only hand tracking. We're looking at you, Apple Vision Pro. Some devices support one or two controllers. So for example, the Magic Leap typically has one controller, and Quest and Pico have two controllers. Some devices support both hand tracking and controllers, so Quest and Pico, for example. And that actually has its own challenges, because if you're trying to deploy content for Quest or Pico, you have to know whether or not the user is going to be using their hands or their controllers, and somehow tailor your experience to work in both of those cases. Some headsets support neither. So, for example, you may remember Google Cardboard, which is actually one of the inspiring technologies for Zapbox. Google Cardboard was a cardboard headset that you put your phone into and lets you view virtual reality experiences. And in Google Chrome, Google have supported WebXR for the Google Cardboard, but that device doesn't have any controllers whatsoever. So what we see here is a challenge. It's how can we build content once, as is the promise of WebXR, and have it work across all of these devices, even if we're not able to know physically how the user is going to be interacting with that experience. The final layer of this cake of ecosystem is developer tooling and creative tooling. And what we'll see is it begins the turn of our emotional roller coaster back up to delight. We have a tool called Mattercraft at Zappar, which I'll talk about, but there are some other engines that are great and we should mention also. Wonderland, for example, is a WebXR content creation tool, and it focuses on high performance for big experiences, perhaps with multiple areas and environments. PlayCanvas is a 3D development environment for the web, and it's evolved into WebXR as that specification has arrived. But we now enter the second shameful plug, which is to talk about Mattercraft. So at Zappar, we've been building content, this kind of content, for these 13 years. And one thing that was missing for us was developer tooling targeting the web, in particular for AR, VR, and WebXR. Native app developers who are building apps that run in the app stores are used to great tooling like Unity and Unreal, and have developed sets of ecosystems around those tools to help build big interactive 3D content. But there's been a gap for the web where that's not been possible. And so we built Mattercraft. Mattercraft aims to take some of the rough edges, I suppose the bad and the ugly in WebXR, and make a unified environment for developers. So, I suppose, unfortunate technical words, unified input abstraction. That means Mattercraft provides a way for developers to build content where the input that the users have is translated into a single signal in the engine for the developer. So if you're a user using hand tracking, the user can point and tap their finger to select on an object. If they're using a controller, like the Zapbox controller, they can aim it and pull the trigger to tap on that object. Or if they are using other technologies like Vision Pro, there are other input mechanisms that factor in. As a developer, you don't need to worry. You build once using the pointer event in Mattercraft, and your content works. Other important elements which are not part of the WebXR specification, but have to be part of WebXR content, is user movement and locomotion. That is enabling users to be able to move to an area over there in an experience without having to physically walk all the way over there to the experience, especially if there's a wall or other includer in the way. Other engines like Unity and Unreal have many of these features already that they've implemented against the native specifications. What Mattercraft is able to do is provide those implementations for WebXR. We can also implement additional and useful functionality on top of the specification. So, for example, the WebXR specification provides the web page that's running with information about the position and rotation of the bones in your finger when it's tracking your hands. And you can see here in this little GIF, we're able to use those positions to detect gestures and enable novel user experiences within the content. There are also workarounds for browser bugs and inconsistencies in WebXR. And in some ways, it's a good sign that browsers have some bugs, because it means they're evolving and they're experimenting with this technology. And we wouldn't all be here today if we weren't excited about that happening. Thankfully, Mattercraft is able to react quickly to these changes. We test Mattercraft and its content across a number of different devices when there are updates and operating system changes, etc. And we're able to smooth out all of those bugs so that content developers don't have to worry about them. There's a long tail of additional functionality that Mattercraft provides. I'll mention just a couple here. We have a comprehensive rendering engine that's powered by Three.js. That was one of those components in the ecosystem that I mentioned on an earlier slide. What we've tried to do with Mattercraft is embrace that front-end web development ecosystem. Because at the end of the day, when you're building content for WebXR, you're building a web page. We're embracing that ecosystem because it's very good. There are huge numbers of front-end web developers, and they're all producing fantastic content, be that libraries and SDKs, examples, a community around front-end web development. And we'd like XR developers to be able to take advantage of that. We'd also want that those developers get the benefits that go beyond what the front-end web development ecosystem normally provides. If you're a front-end web developer and you're making a web page or a website, a traditional one, you don't have any concern about 3D typically, and you don't understand some of those things that an XR developer is going to be caring about. And so with Mattercraft, while we make available that ecosystem, we also abstract it to the extent that allows content developers not to worry about it if they don't want to. That means if you are a front-end web developer, you'll come to Mattercraft and you'll immediately see how it works and how it maps to your existing knowledge. But if you come to Mattercraft as perhaps a 3D developer, or maybe even with no XR experience yet at all, you're going to find an environment where you don't have to worry about learning any front-end web development things. It will work for you, and it will be simple to use. Zappar, we call this progressive complexity. A couple of other bits I'll mention here. Mattercraft has fully baked animation tools. And this is kind of special because these types of tools haven't been seen well on the web before. Things like keyframed timeline animations with additive blending and all of the other, I suppose, fancy things that animators use. These are built directly into Mattercraft, and it means that content developers can build animated, stateful, interactive experiences without having to reach for other tools. We, of course, have a fantastic physics engine built into Mattercraft. We have real-time collaboration, and we have an always-on live preview that updates as you're working with your content. That means that I can be working with Mattercraft on my computer, and I can be wearing a headset like Zapbox or Apple Vision Pro, and as I'm working in Mattercraft, those changes are reflected live into the environment as I'm seeing it through the headset. That means that as I'm iterating on this content, I can do it very quickly and efficiently. Zappar, we also support other types of AR and VR in addition to WebXR, such as face filters and world tracking. So with WebXR, we don't have to think about it as the Wild West. It provides an environment for us to have rapid development of content, seamless deployment of content, and no app downloads for users. At Zappar, we fundamentally believe that the web is the ultimate application platform. I'm pleased to announce that we have just dropped the beta tag on Mattercraft. Mattercraft has graduated from having been in beta for 6 months, and so at Zappar we're now supporting Mattercraft for content in production across many of our clients and businesses. And you can get started at mattercraft.io if you'd like to give it a try as well. If you have any questions, feel free to come and grab me after the talk. We're also on booth 217, and you can try Mattercraft there, or indeed be pleasantly surprised with Zapbox. Thank you very much for listening to me, and have a lovely rest of your show.